Milne's predictor and Milne's predictor corrector method. Milne's predictor corrector method for solving ODE differential equation. Suppose you have a differential equation dy dx, that is y dashed equals to f of x comma y. This is the differential equation. You have to solve this differential equation using Milne's predictor corrector method. Okay, so Milne's predictor corrector method, this is multi-step method. Okay, just like modified Euler method, this is multi-step method. To compute yn plus 1, a knowledge preceding values of y and y dashed are required. Okay, to compute yn plus 1 in knowledge of preceding values of y and y dashed means dy dx is required. Okay, now for predictor formula and open type quadrature formula and open type quadrature formula is used to derive the predictor formula. An open type quadrature formula is used to derive the predictor formula. For Milne's predictor formula, we use open type quadrature formula, and for corrector formula, a closed type quadrature formula is used. A closed type quadrature formula is used for corrector formula. Okay, so for predictor formula is derived from open type quadrature formula and corrector formula is derived from closed type quadrature formula. Now write the formula, predictor and corrector formula. Predictor formula: y n plus 1 p. Yn plus 1 p mean the n plus 1th value of y. This is the predictor value of n plus 1th value of y. Okay, this is predictor. Yn plus 1 p equals to y n minus 3 plus 4h by 3 2 ym minus 2 dashed minus yn minus 1 dashed. Sorry, this is yn minus 1 dashed plus 2y in dashed in prime. Okay, so yn plus 1 yn plus 1 p equals to yn minus 3 plus 4h by 3 2yn minus 2 prime minus yn minus 1 prime plus 2y in prime. Okay, this is predictor formula, Milne's predictor formula. Milne's predictor formula. Milne's predictor formula. Okay. So predicted value of yn plus 1 equals to yn minus 3 plus 4h by 3 yn minus 2 prime minus yn minus 1 prime plus 2yn prime. Mean second order derivative, first order derivative of y at the point n minus 2. This is Milne's predictor formula. Okay, now write corrector formula. Yn plus 1 c, corrected value of yn plus 1 c equals to yn minus 1 plus h by 3 yn minus 1 prime plus 4yn prime plus yn plus 1 prime. So yn plus 1 c equals to yn minus 1 plus h by 3 yn minus 1 prime plus 4yn minus yn prime plus yn plus 1 prime. Okay, this is Milne's corrector formula. Milne's corrector formula. Okay, so for to derive this predictor formula, Milne used open type quadrature formula. For corrector formula, Milne used closed type quadrature formula. Okay, now write one problem. Compute y bracket 2. Compute y bracket 2 from the differential equation. From the differential equation. Dy dx equals to 1 by 2 x plus y. Given that y bracket 0 equals to 2, y bracket 0 is 2, y bracket 0.5 equals to 2.636, y bracket 1.0 equals to 3.595, y bracket 1.5 equals to 4.968. Okay, so you have to compute y bracket 2 from the differential equation. Dy dx equals to half x plus y. The initial conditions are y bracket 0 equals to 2, y bracket 0.5 equals to 2.636, y bracket 1.0 is 3.595, y bracket 1.5 is 4.968. Okay, we have to solve this problem using Milne's predictor-corrector formula. Okay. dy dx equals to, given that dy dx that is y dashed equals to half x plus y. This is the differential equation. Y dashed equals to half x plus y. So you can write yn prime equals to half xn plus yn. Yn prime equals to, yn prime means derivative of y at xn point. At xn point, derivative of y. Yn prime equals to half xn plus yn. Yn prime. This is derivative of y, that is dy dx at the point xn. That is half xn plus yn. Okay. Now x0 is 0. This is x0. x1 is 0.5. x2 is 1.0. x3 1.5, and we have to calculate y2. So x4 is 2. So you can say h is 0.5. H equals to 0.5. x0 0, x1 0.5, x2 1.0, x3 1.5, x4 2. x4, the point where we have to calculate y. Okay, this is the xn point. At that point we have to calculate y. So x4 is 2. So these nodes x0, x1, x2, x4, x1 is, so x0 0, x1 0.5, x2 1.0, x3 1.5, and this is x4. Okay, at that point we have to calculate y. So these nodes x0, x1, x2, x3, x4, these nodes are equispaced nodes. So step length h equals to 0.5. Now y0 is y0 equals to 2, y1 equals to 2.636, y1 2.636, y2 is 3.595, y3, this is 4.968, and we have to calculate y4 using Milne's predictor-corrector formula. Now Milne's predictor formula is what? Predictor formula yn plus 1 p, mean predicted value of y at the point xn plus 1 is yn minus 1 plus 4h by 3 2y n minus 2 prime minus y n minus 1 prime plus 2y n prime. So yn plus 1 p equals to yn minus 1, yn minus 3, sorry, this is yn minus 3 plus 4h by 3, 2y n minus 2 prime minus y n minus 1 prime plus 2y n prime. Now we have to calculate y4. So y4, so n plus 1 is 4. Okay, so n plus 1 equals to 4. That implies n equals to 3. So n equals to 3. So y from Milne's predictor formula, y 3 plus 1, so it is 4 P y predicted value of y4 equals to, so in place of n just write 3. So y3 minus 3, it is y0 plus 4h by 3 2y1 prime 2y1 prime plus minus y2 prime plus 2y3 prime. So y4p equals to y0 plus 4h by 3 2y1 prime minus y2 prime plus 2y3 prime. Okay. Now we have to calculate y1 prime, y2 prime and y3 prime. y1 prime, y2 prime and y3 prime. Now y1 prime equals to half x1 plus y1 prime is y1 half x1 plus y1. x1 equals to, x1 is 0.5, y1 is 2.636. So y1 prime equals to y1 prime, this is 1.568. So y1 prime is 1.568. Okay, 1.568. Next, calculate y2 prime. So just write y1 prime equals to, y1 prime is 1.568. Next, y2 prime is, in place of n just write 2. y2 prime equals to half x2 plus y2. So y2 prime equals to half x2. x2 is 1.0 and y2 is 3.595. So y2 prime equals to 2.2975. So y2 prime is 2.2975. So y2 prime is 2.2975. Okay. Next, y3 prime. y3 prime is x3 plus y3. So y3 prime equals to half x3. x3 is 1.5 and y3 is 4.968. So y3 prime equals to 3.234. So y3 prime equals to 3.234. 3.23. Okay. So put all these values, y1 prime, y2 prime, y3 prime here. So y4p equals to y0. y0 is 2 plus 4 into h is 0.5 by 3. 2 into y1 prime. y1 prime is 1.568 minus y2 prime, that is 2.2975 plus 2 into y3 prime, that is 3.234, and simplify. So y4p equals to, this is 4.4355. So the predicted value of y4 is 4.4355. Okay. Now you have to use corrector formula for y4. Okay. Now Milne's corrector formula is mean this is y4p. So y4p equals to 4.4355. 4.4355. Now Milne's corrector formula is Milne's corrector formula is yn plus 1 c. This is corrected value of yn plus 1 equals to yn minus 1 plus h by 3 yn minus 1 prime plus 4 yn prime plus yn plus 1 prime. So yn plus 1c equals to yn minus 1 plus h by 3 yn minus 1 prime plus 4 yn prime plus yn plus 1 prime. Okay, now we have to calculate y4. So n plus 1 is 4. So n equals to 3. Okay, so y4c equals to n3. So this is y2 plus h by 3 y2 prime plus 4 y3 prime plus y4 prime. This is corrector formula. y4c equals to y2 plus h by 3 y2 prime plus 4 y3 prime plus y4 prime. So we have to calculate y2 prime, y3 prime and y4 prime. Okay. Now first iterative value of y4 from the corrector formula, calculate first iterative value of y4. So y4 1. What is y4 1? y4 1 in bracket 1 means the first iterative value of y4 using corrector formula. y4 in place of c we are writing 1, means the first iterative value of y4 using corrector formula. This is equals to y2. What is y2? y2 is 3.595 plus 0.5 by 3. y2 prime is 2.2975 y2 prime is 2.2975 plus 4 into y3 prime, that is 3.234 plus y4 prime. What is y4 prime? Okay, so we have to calculate y4 prime. Now y4 prime equals to half x4 plus y4. From this equation, differential equation, y4 prime is half x4 plus y4. So y4 prime equals to half x4 is 2, x4 is 2, y4 prime, y4 prime goes to half x4 plus y4, and y4 is the predicted value of y4. y4 is predicted value of y4, that is 4.4355. y4 prime is half x4 plus y4. We use the predicted value of y4, that is 4.4355. So y4 prime 4.4355. This is wrong. This is the predicted value of y4 from predicted formula. This is 6.8710. predicted value of y4 from this formula y4p. What is y4p? y4p is y0. y0 is 2 plus 4 into 0.5 by 3 into y0 plus 4h by 3 y1 2 into y1 prime 2 into y1 prime is 1.568 2 into 1.568 minus y2 prime is 2.2975 minus 2.2975 plus 2 into y3 prime y3 prime is 3.324. This is 3.324. Okay, and simplify. This is 6.8710. This is actually 6.8710. This is not 4.4355. This is not 4.4355. This is wrong. Okay, this is actually 6.8710. So the predicted value of y4, is 6.8710. So right here 6.8710. So the predicted value of y4 is 6.8710. This is the predicted value of y4. This is actually 6.8710. This is not 4.4355. Okay, this is 6.8710. Use this value here. Okay, this is 6.8710. So the predicted value of y4 prime equals to half x4 plus y4. So y4 prime is half x4 is 2 y4. Use the predicted value of y4, that is 6.8710, and simplify. This is 4.4355. This is 4.4355. Okay, so y4 prime is 4.4355. So now we have to calculate the corrected value of y4, that is y4, first iterative value of y4. y4 equals to y2. This is y2 plus h by 3, 0.5 by 3. y2 prime is 2.2975 plus 4 into y3 prime 3.3244, 3.234, this is 3.234. Okay, 3.4 into 3.234 plus y4 prime, and y4 prime is 4.4355. 4.4355. Okay, so the first iterative value of y4 prime, y4 in bracket 1 means the first iterative value of y4 using character formula. Use this character formula to calculate y4 1. So that is y2 plus y2 3.595 plus h by 3, 0.5 by 3, y2 prime, this is y2 prime, plus 4 into y3 prime plus y4 prime. This is y4 prime, and y4 prime is calculated from this formula. y4 prime is half x4 plus y4. So y4 prime is half x4 is 2 y4, and y4 is calculated from predictor formula of Milne's predictor formula. So Milne's predictor formula y4p is 6.8710. Okay, and calculate y4 prime. y4 prime is 4.4355. So put here 4.4355 and simplify. So the first iterative value of y4 equals to, this is 6.87317. 6.87317. This is the first iterative value of y4. So y4 1 equals to 6.87317. Okay. Now we have to calculate the second iterative value of y4. y42. y42 is what? Second iterative value of y4 from character formula. This is the character formula use this formula to calculate the second iterative value of y4. That is y2. What is y2? Okay, y2. Y2 is 3.595. 3.595 plus h by 3.5 by 3. Y2 prime. Y2 prime is 2.2975 plus 4 into y3 prime. Y3 prime is 3.234 plus y4 prime. Now we have to calculate y4 prime. Okay, y4 prime. Now we have to calculate y4 prime. So y4 prime is half x4 plus half x4 plus y4. x4 plus y4. Now we take the first iterative value of y4. The first iterative value of y4. Okay, so y4 prime equals to y4 prime is half x4 plus y4. Now in place of y4, now write the first iterative value of y4. For the first case, we have written y4 prime equals to half x4 plus y4. Now for that case, we have taken the predicted value of y4. This predicted value of y4. Okay. Now for calculating y4 means second iterative value of y4, in place of y4 prime, now y4 prime is half x4 plus y4, that is the first iterative value of y4. So it is half 2 plus y4 prime, y4 1. What is y4 1? y4 1 is 6.87 6.87317. So y4 1 equals to half 2 plus 6.87317. This is equals to 4.4365. So this is 4.436585. Okay. So in place of y4 prime, write 4.436585 and calculate the second iterative value of y4. Okay, so y4 1. The first iterative value of y4 is 4.436585. This is the first iterative value of y4. Now this is the second iterative value of y4. This is second iterative value of y4. y4 2 equals to, this is 6.87 6.8733. So the first iterative value of y4 is, so second iterative value of y4 is y2, this is y2 plus h by 3, y2 prime, this is y2 prime 2.2975 plus 4 into y3 prime, this is y3 prime plus y4 prime. For y4 prime, this is half x4 plus first iterative value of y4, x4 plus y4. Now in place of y4, we are writing y4 1. y4 1 is what? The first iterative value of y4. So it is half plus 2, 6.87317 and simplify. This is 4.436885. So put here 4.436885. Okay, calculate second iterative value of y4. So the second iterative value of y4 is 6.87 475. This is second iterative value. So second iterative value of y4 is 6.8733475, and the first iterative value of y4, is 6.87317. Okay. So y4p is predicted value of y4, y41 is first iterative value of y4, y42 is second iterative value of y4. Now see, y4 and y41 and y42, these are approximately equal. Connect up to 3 decimal places. So y41 approximately y42 in bracket correct to 3 decimal places. So y4 is 6.873 in bracket correct to 3 decimal places. Okay. Therefore, y2 equals to this. Y4 is what? Y2, that is 6.873 in bracket correct to 3 decimal places. This is by Milne's predictor-corrector. So before we stop today's class, just write one homework for Milne's predictor-corrector method. Right. Compute homework. Compute y 0.5 from the differential equation dy dx equals to 2 into e to the power x minus y. Compute y 0.5 from the differential equation, y 0.5 from the differential equation dy dx equals to 2 into e to the power x minus y, given that y 0.1 is 2.01, y 0.2, this is 2.0401, y 0.3 is 2.0907, y 0.4, this is 2.1621. Compute y 0.5 from the differential equation dy dx equals to 2 into e to the power x minus y. These are the initial conditions. Y 0.1 2.01, 2.01, y 0.2 is 2.0401, y 0.3 is 2.0907, y 0.4 is 2.1621. Okay, so you have to calculate 0.5. Okay, the right answer is 2.2553, correct to 4 decimal places. Correct to 4 decimal places. So for this problem, x0 is what? x0 is 0.1, y0 is 2.01, x1 equals to 0.2, y1 is 2.0401, x2 is 0.3, y2 is 2.0907, x3 is 0.4, y3 is 2.1621, and x4, that is 0.5. You have to calculate y4. Okay, so you have to calculate y4. So use predictor formula for finding y4p first. Predictor formula for finding y4p. For that purpose, you have to calculate y1 prime, y2 prime, and y3 prime. Now, the differential equation is dy dx is 2 e to the power x minus y. So y dash is 2 e to the power x minus y. So you can write yn prime equals to 2 e to the power xn minus yn prime means first order derivative of y at the point xn, 2 into e to the power xn minus yn. Okay, use this formula for finding y1 prime, y2 prime, y3 prime. Okay, what is yn prime? That is the first order derivative of y at the point xn, 2 into e to the power xn minus yn. Okay, use y1 prime, y2 prime, y3 prime for finding the value of y4p. Then apply corrector formula. Corrector formula for finding the values of y41, y41, y42, like that. Okay. Now for y41, you have to put the value of y4. Okay. Use y4p in that case for finding the y4, for finding y41, that is the first iterative value of y41. Use y4p in that formula. And for finding the value of y42, use the value of y4 as the first iterative value of y4. Okay. In the formula, in the corrector formula for finding the second iterative value of y4, you have to use y4, the first iterative value of y4. Okay. Now you can stop now. Next day we will start numerical solution of partial differential equation. Okay.